Hi guys. Okay, so homework take up. Remember what I was telling you yesterday. When you do practice question number 1, the very first thing I suggest is that you take the information that's in the chart and transfer it onto the diagram so that it's a little bit easier to see where things fall. So, the voltage of the battery is 240 V. The current of lamp 1, I see these say resistor 1, don't worry about that, that was a little typing error, but lamp 1, resistor 1, the current here is 5 amps. And what else? The lamp number 2, the voltage is listed as 70 volts. And lamp 3, voltage is 70 volts. Okay, so you can start however way you want. My suggestion is to think about current first, because it seems to be the one that's a little bit easier to understand. So if the current flowing through resistor number 1 is 5 amps, and it's a series circuit, nothing's going to happen to that current anywhere. It's going to be the same throughout the entire circuit. So right away, current here is going to be 5, current here is going to be 5, and you do not add them up and say the current was 15 at the start, because that makes no sense. If it was 15 at the start, how would it split up into 5, 5, and 5 if there's only one path? So that means that the answers here would be 5 amps, 5 amps. So they're, all three of them are 5 amps, and back at the battery the current is 5 amps. Voltage works a little differently. 240 volts leaves the battery, and a little bit of voltage has to be dumped off at every single component in this circuit, and it's all got to be dumped off before it's over. So 70 gets dumped off at the first, 70 gets dumped off at the second. How much would be left over? So think about that, because it's not 70, 70, and 70. They're not all the same. It dumps off 70, dumps off 140, and must dump off 100 more on that last load, last resistor, last lamp, whatever it is, before it goes back to the battery. And that's it for that question. So again, no calculators, no formulas. You just have to think about the rules. Question 2. This is actually the very first example of a parallel circuit. So this is an important one to have in your notes. I already wrote on here yesterday when I was making the video, so I already have 70 volts, 70 volts, and 70 volts written on there. Okay, think about a parallel circuit. The current is going to split up and go 3 different ways, and each electron can only go one of those 3 different ways. Each electron is going to pass through one resistor, and only one resistor, before going back to the battery. So they have to dump off all of their voltage at that one resistor. So if lamp 2 and lamp 3 are 70 and 70, lamp 1 must be 70 as well, because the theory here is all of the voltage from the battery gets dumped off at the one resistor. So the voltage of the battery must be 70 as well. So every single electron picks up 70 volts at the battery and dumps off 70 volts at whatever resistor it goes through. Current is going to divide up. So whatever the current is at the battery, and it's listed, the current is 12.5 amps. 12.5 amps is going to split 3 different ways. Sometimes it's the same, sometimes it's not. I said yesterday, I think that in this grade, most likely it's going to be the same. In this question, it's not. Lamp number 1, or resistor number 1, that's this one here, is 2.5 amps, goes this way. Lamp 2, we don't know. And lamp 3, or resistor 3, is 4 amps. So the question is, what happens here? What is the middle? So just think about the theory behind current in a parallel circuit. It splits up, and the only way that you can tell how much there is at the battery is to add them all up and put them back together again. So 2.5 and 4, that's 6.5. The missing current in the middle must be 6, because 4 plus 6 plus 2.5 would be a total of 12.5, and that's how much left the battery. So filling in the last thing in the chart here would be a 6 amp entry in that chart. Those are the two main questions, I guess. If you understand those ones, I would say that for now you're done. But let's try this. Let's try this mixed circuit and see if you can make heads or tails of it. A little bit trickier, but again, transfer what you know. The battery has a voltage of 120. So 120 volts is going to leave the battery and has to be dumped off around the circuit. Lamp number 1, 30 volts gets dumped off here. And lamp number 3, 10 volts gets dumped off right there. Okay, can we do anything with that without even looking at current? Yes, you absolutely can. These two, lamp number 3 and lamp number 2, are in parallel. And when resistors or lamps or loads of any kind are in parallel, they have the same voltage. The same voltage gets dumped off when the current splits here. Some of the electrons are going to go through here and dump off 10. That means that the other electrons that went through here are going to do the same thing. They're going to dump off 10 and then join back together again and back to the battery. Okay, but be careful here, because that means we need the missing voltage of lamp number 4. And the mistake, the most common mistake, is to say that it is 70 volts. That's wrong. If you don't even understand where 70 came from. Some people in the class definitely will say that it's 70 because they'll look at this diagram and say that there's 30, 40, 50 dumped off already, and so there would need to be 70 here. Well, here's the problem with that train of thought. Every electron is going to go through this lamp and dump off 30. But then the electrons are going to split and go two different ways. And they're only going to dump off 10 if they go this way. They're only going to dump off 10 if they go that way. Then they join back together again. So there isn't 30, 40, 50 volts dumped off. There's a total of 40. 30 get dumped off here. 10 get dumped off in whatever branch of this circuit the electrons go through. So they've lost 40 up until this point. So lamp number 4 has to be 80 volts of energy dropped off there. And then back to the battery. So filling the chart, 120, 30, 10. Lamp number 2 would also be 10. And lamp number 4, kind of an advanced concept there, would be 80. What about current? Let's see if current is a little bit easier. Lamp number 1, that's up here, is 7 amps. And lamp number 2 is 3 amps. Oh yeah, that's going to be easy. Well, I say it's going to be easy because I've done this before, of course. Let's start here with lamp number 1. Every electron passes through lamp number 1. So if there's 7 amps of current passing through lamp number 1, that means 7 amps left the battery. There's no division. There's no splitting up at that point. So 7 is the total. 7's the current for this entire circuit at any point. So 7 amps leaves the battery, 7 amps passes through lamp number 1, and then it's going to split. Some of it's going to go this way, some of it's going to go that way. So one of these two has to be told to you already, and it is. Lamp number 2 has 3 amps pass through it. That means that lamp number 3 must have 4 amps. Because 7 amps split up into 2 different parts, and one of them is 3 already. Then they join back together again and continue down the rest of the circuit. Lamp number 4, the current here would be 7 amps again. So think about only those numbers. Ignore the voltages if you can, and just look at the amperes. 7 amps leaves the battery, travels through this component, splits, and goes 3 and 4, then comes back together again and is 7 one more time before it gets to the very, very end. This is weird. It divides the class up because some of you have taken tech classes downstairs and you know this stuff like the back of your hand. You're so far beyond this. You're into way more advanced work than what we're doing here. But, you know, take it as a good refresher. And for those of you that are learning this for the first time, You will continue this work in college programs and in university programs, so we can't skip this work. And remember, the only assessment is going to be an online assessment that you can do using your notes. There's no tests or no exam. So learn from your mistakes on here. And don't worry if you're making mistakes. That's what this is all about. Filling in the rest of this chart. If you just want to check and see if you had these 7 amps, 4 amps, and 7 amps. And then the voltages I already wrote on there. So that's it for today. Check this over, and more importantly, instead of just checking it over, focus on the ones that you got wrong. See if you can look at it again, especially since this really takes no time or effort. See if you can look at it again. Rewind this video and start over a certain question again if you need to listen to it again. And see if you can just get a common sense. I don't want to use the word common sense because then it sounds sort of bad if you don't get it. But see if you can sensibly understand without using any written laws, any boxed formulas, because that's the point. You want to be able to intuitively get these numbers without needing to read it off a formula sheet, these Kirchhoff laws for current and for voltage.